Hey all, Rob Asher from Giraffe here. I'm going to show you how to do a property feasibility with Giraffe. Now feasibility is a kind of a modeling. It's a modeling exercise, and as a financial modeling exercise, whether you're doing a feasibility for a lemonade stand, coal mine, or property development, it's about looking at your costs, modeling them out, your unit costs, cost per lemon, cost of labor, cost of equipment, taxes, fees, consultants, rent, and then your revenue, value per lemonade, and then seeing if you're profitable. Same with property. The only difference with property is that property is inherently spatial, and it's all property developments that have ever happened in human history have happened somewhere on this map, except for metaverse developments. But we are not talking about the metaverse. We're talking about the universe. Okay, so let's assume that there's a new hospital in this region, and that's the government has made an investment and they're making a new hospital. New hospital, there it is. It's going to sit right there between Macmillan and Peacock Street, and it is going to drive demand. It is going to mean there's doctors, there's nurses, there's also radiologists, all sorts of professionals and people that are going to move into the area. They're going to want to live nearby to the hospital, and so the existing zoning, which is currently R2, which is a New South Wales zoning for low density residential, so like suburban, is going to be intensified. So you can see on the satellite below, there's the houses, there's the backyards. Pretty soon there's going to be apartment blocks, and we are going to make one. I'm also going to bring in the cadastre. Cadastre is a fancy word for property boundary or parcel or lot. All right, so let's acquire some cadastres. So I'm just going to edit this project boundary, and I'm going to set it to this parcel, and then I'm going to stretch it to, let's make it big. Let's make it big, why not? Okay, 5,700, adjacent to the hospital, and we're gonna do this feasibility nice and quick. Okay, so before we do the geometric modeling, the 3D modeling, let's get the foundations of our financial modeling done properly. So Giraffe uses this concept of usages, and this is a residential usage, and you should think about this as the input sheet to an Excel model. So these are just numbers. I can say floor to floor is like 9 million. Giraffe doesn't mind. But 3.1 is about right, because that is sort of, double a human. So when you walk into a space, you're expecting that kind of ceiling height. Hard costs and soft costs are American terms for construction costs. So we're going to do a construction cost. And let's say we're going to build our units for $4,000 a square meters. And then I'm going to add our consulting fees, consulting fees. And that's going to be, say, 20%. So what did I say? 4,000, so 800 bucks. And again, per square meter, 4,800. So then I'm going to save. Oh no, I'm going to go to. Oh no, I will save that. A yes, I know. A yes. I'll go to retail. We'll do a similar exercise. 251 square net rent. So retail, we rent rather than selling. Oh, sorry. The reason I paused there is we need to set our prices for our units. So currently they're defaulting to like a weekly price, right, of rent, but we're going to be selling these things. So these 1 beds we're going to sell for 800, 1, 2, 3. Our 2 beds will sell for 1 million, 1, 2, 3, and our 3 beds will sell for 1.4 million. Okay, and let's make them about the right size. They're bigger than normal. This is a, this is a leafy. There's going to be doctors and stuff. So this is upper end of the market. So we want some size. And note this consulting fees. This is including things like your cost of sales, your architect design, the town planner, and probably even some of your taxes and charges and levies. Okay. So without further ado, let us start designing. So you can see, sorry, the financial modeling, we've done the inputs. There's currently no outputs because we need some 3D geometry to get some outputs. So let's draw some. This is what I love about, real estate is you can be creative, right? You can draw something like that, or you can draw something like that. And this, they cost the same. There's no change in the numbers. There's no change in the areas. But in this one, you're building to the front of Macmillan Street, and so you're overshadowing the south of your own site. In this one, you're overshadowing someone else, right? So you're getting different effects, and depending on what use this is, this could be very beneficial to you or not. So you can be very creative in the design process, which is what's really nice about property. So in this instance, what we're going to do is we are going to build an L-shaped building like this. And what I'm imagining is a ring. Let's actually model it out explicitly. a ring of cafes, and then down here, like a Coles, which needs a bigger footprint, something like that, right? So here's the cafes. We can put a little park over here, and landscape simple, and we are going to have this little laneway, and so I'm imagining, there'll be like the BWS and all that stuff, and then there'll be the Coles, right? And then over the top of it, let's pop some residential uses. Okay, there we go. And you can see as soon as that appears, there's the shadowing, right? And you can see that as soon as we start doing that, the neighbors are going to start complaining. The owners of this property are going to say this is the worst thing that's ever happened. And they may very well be right. So this is going to be a contested, this feasibility is going to depend on what we can pass. This is kind of like an opening gambit. It's going to be negotiated. But let's continue on our modeling quest to actually get the feasibility modeled out. So I'm going to just use Giraffe. We can start from scratch, but I'm going to open up one of our templates, which is this build to sell template. And it's got a bunch of sections. It's got a built form section, an income section, a cost section, and then a report section. The built form section, very simple. It's just giving you the areas. This geometry, if I add extra levels, the number of dwellings goes up. The areas go up. The gross and the net go up. The gross is the area including the lift shafts, the services, the air conditioning, and the corridors. The net is what you actually sell. As in, you can't sell a corridor as part of an apartment, but you have to build it. It still costs you. You have to put carpets on it, lights, concrete, but you can't sell it. So that's in this building here, in this little lump of geometry, there's about 3,000 square meters of cost that you can't sell. So we're taking that into account. Next section is the income. So we're making a healthy pile of cash. Total apartment sales is $118 million. And that's counting up from our inputs. That's counting up, these numbers times the relevant numbers of units. And if we change this, so if we make more 3 beds, say that didn't really change the price, but because probably our square meter rates are actually quite similar. Yeah, quite similar. So it's 1 to 1 and 140 to 140. So they're about the same. So if I make those 3 beds, say there's overwhelming demand for 3 beds, I save that. We can actually get a huge premium and the more 3 beds. If we're selling 3 beds at a higher per square meter rate, we should make more of them. Always optimizations to be had in unit mix, etc. Our total potential retail rent is equal to the saleable area of the retail times the net rent. And the net rent is, if we go to the retail usage, $250. So there we're assuming that that's net, obviously, right? So the gross rent, they may be paying us $500, but then we're paying $250 for property management, maintenance, cleaning, blah, 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 blah. And we may actually change that to times 12. Let's say that's the monthly rent. Save. Boom. That goes up to 8 million. That seems more likely, right? The retail vacancy, and we're doing 2 kinds of feasibility here, right? So the income there's apartment sales, and that's just, we build the apartments, we sell them. We're not going to rent them out. Whereas the retail, we're doing a different strategy. We are going to rent it out for a total potential rent of 8 million if it was 0 vacancies. But we're going to assume 5% vacancy. So in all these tenancies, these cafes, this BWS, 5% of the time, or 5% of the time it's vacant, or at any one time, 5% of the area is vacant. And then we're going to put in a cap rate of 4%. And that is the value which we convert an annual rent stream into a value, as in, that's what the cap rate means. And so our stabilized potential rent is, our stabilized retail value is our total potential rent multiplied by the vacancy factor, so 1 minus the vacancy rate, divided by the cap rate. There we go. So a cash flow of $8 million, 5% of it at a 4% cap rate is worth $200 million. So if the buyer only needs to make 4% a year on their investment, they can put $200 million into this thing and be happy. This is why real estate is so sensitive to the cap rate. So that gets to 9%, say if changes. Yeah, that's now $90 million. And if the cap rate goes to 1%, like when interest rates fall very, very far, or sometimes you see them done at 3%. We're $264 million. So just that macro environment can absolutely drive this thing. So your total income then is 134 plus 264, 398. All right, so you can see we're just doing an all feasibility here. Costs of things. Also, we're doing income first. Now we're onto the costs. So your hard costs, your financing costs, your soft costs, your developer fee, and your contingency. Our hard costs are laughably low because we're using the wrong input. We're using this hard cost. So let's actually go to, what did I call it? Construction cost. Right, and I'll save that. And we need to save changes. So that's only applying, we only added construction costs to the residential usage. We didn't assign it to the retail usage. So we need to make sure that we do that. So that 4,000 I'm going to copy to the retail as well, and I'm going to save that change. And you can see that construction cost, that hard cost jumps up to 77 million. So hard cost is equal to, I could rename that actually. Construction costs. All right, save changes. And then your soft costs is 15% of hard costs. So this could be fees, taxes, consultants. And we're just taking that 77 million and multiplying it by 0.15. Financing costs, we've got a fixed $200,000. I feel that's low for a development of this size. Let's bonk it up to 2 million. Developer fee, 3% of construction plus financing plus fees, taxes, and consultants. And we've got a contingency here, which is equal to everything times 0.1, so 10% of it all. All right, so those are our costs. And then we can look at our return on cost. And our return on cost is currency in the cost, so 103 million. Our total income is 398 million. So you just do that and see what we got. 284%, which looks, you put in 103 million, you walk away with 298 million. You've made a 284% profit. So it looks like a really good development here, which means our inputs are probably wrong. Or what it means is that our land cost, which is not in here, which normally you back solve to, is going to be a high percentage of that. So we could, you could do the sums now to work out, say you needed to make a 20% return on cost, what you would pay for the land to hit your number. So you could back solve there. But I won't do that because I don't want to take up too much of your time. So the main things I want to just reiterate is the feasibility side of things, as in the normal feasibility, like the lemonade stand feasibility, which just looks like this. This is it's called a straight line feasibility because it's in a straight line. So we're not doing sensitivity analysis. We're absolutely ignoring the time value of money. So your return on cost, 284%, that's epic. But if this takes 200 years to build, not so epic, right? You make a real loss. So depending on how long this takes and the approval times and then the construction time and then the sales time, it can be really big. And obviously every single variable in this thing could be tested and sensitivity tested, etc. But what we've done really nicely is connected this little model with this little feasibility, and it's actionable. Like you can start a discussion now. You can go to people and talk about this this scheme and why you'd be doing it and why you wouldn't. And as you're doing it,